Okay, here's the second part of the drawing videos. This is a little more complicated, so I'm doing it second. It's listed as 35A, but it probably should watch 35B first. I did the simpler one first. Let's see what it looks like first of all. It's a window. Okay, you can see it there. And I can select a color and I can start drawing. Wow. And select another color and draw, and more of the same type thing. I mean, it's proof of principle. You can do other stuff. There's also a white. Okay, and there we go. And there's a clear button. All right, that's what it's going to look like. Next question is, how do we do it? Let's bring up the Glade window and get that down. Well, it's relatively simple. First of all, we've got a drawing area. And this is the drawing area. I should probably make it a little bit wider. I didn't realize. Well, here's where the size is. It's 422. Let's fill it all the way out there. Okay. All right. And the height's 261. And that allows me room for buttons down here. In the drawing area, its name is Draw 1. It's positioned at 0, 0, upper left-hand corner. And you saw everything that's important there. I get some margins, but they don't really do much of anything. Only 2 pixels, and there's the size. Under signals, we've got a couple of signals here. Let me widen this out a little bit. Well, move it over here. First of all, we get the button press event. If you press a button in it, we also, in its odd draw 1 button press event, we've got the draw signal, which is when the system wants to draw the image. This is the function it'll go to on draw 1 draw. And we have a motion notify event. If while the mouse button is down, you move. Well, if you get the motion, whether you move it, and if the mouse button is down, it goes to function on draw 1 motion notify event. So those are the signals. Button press, draw, and motion notify. The other ones here are just regular old buttons called clear, and they're packing, of course. They're the signal is on clicked, on clear clicked. Next one is red, on red clicked. Again, notice it's capital R. Green, blue, and white. So those are my buttons, which are going to be used. All right, and we can get rid of that. All right, here is the program. Now what we're going to do is, when we draw, I'm going to hold down the left button and move the mouse. Every one of those mouse movement signals is going to be put into a list structure. And the list structure will have the coordinates, and it'll also have the color. So first of all, well, there's the function. There's a function I'm going to use. It's not one of the callback functions, but it's a function. Here's the structure for a point. It consists of an x coordinate, a y coordinate. I'm only using integer coordinates, although in reality it's, I believe, double. The color of the point, colors are stored as doubles, red, green, blue, and white. I guess we really don't use white. White means red, green, and blue. The white is, I think, not actually used anywhere in here, is it? Nope, that's it. It's the only place it was used. I forgot to delete it because white is red 1, green 1, blue 1. That gives you white. Now watch it, the compiler error on this. But anyway, the color numbers are between 0 and 1. 1 means max, 0 means not. There's a pointer to the next element in the structure and some utility pointers. I don't actually create an instance, I only have pointers because I'll be mail-locking them into existence. We've got some global doubles, which will be the color numbers, because the buttons that set the color are going to set these values, and these values will be used by the drawing program to decide what color the point should be as you are drawing it. All right, let's, where do we want to go here? I set the pointers all to null. I set the colors all to 0. After that, it's nothing really. It's just the usual thing with the builder. Pulling out each of the buttons is the draw 1 object. Clear, red, green, blue, and white. and unref the builder. Okay, GDK. The button motion is part of the GDK system, so you've got to set the events up, telling it that it will be able to receive certain things from GDK. You're enabling the button motion and the button press. So these will be available as events, and otherwise you won't see them. Let's see. Set above, that's meaningless. I mean, you can leave it there or not. It doesn't do anything. All right, and we start GDK. Okay, let's go down the bottom first, look at the color buttons. So if you click one of those color buttons, it comes down here. And all I do is set, as appropriate, red, green, and blue to be, now in the case of red, I set red to 1 and the other two to 0. In the case of green, I set green to 1 and so forth. And white sets them all to 1. So you can get any color you want by blending the colors. So there's my color buttons. All right, let's look at the drawing function. This is the function that will be called when the system wants to draw the window. You saw that in the other video. It's almost the same function, but it works with different data. You get the widget, which is, of course, draw 1, and you also get the pointer to the Cairo worksheet, or the Cairo sheet, level, which is going to contain the image. Now, there's actually no data being passed here. It's just residue. Let's see. I actually don't use these guys. This guy here, and neither of these guys. They were from an earlier version. I'm picking up the height and width of the of draw 1. I don't actually use them anywhere, I believe, but I'm leaving them here if you want to see what they are. But they're the height and width of the drawing window. I set the width of the line to be 1.0, which I don't know what that unit actually is. It looks thicker than 1 pixel, so you'd have to look it up in the Cairo set. The Cairo is a whole collection of functions to do drawing, and you can just type GTK space Cairo and you'll get the list of functions in a Google search. If there's nothing in it, which would be the case after a clear, then you simply return. There's nothing to be done. The clear down here, let's go on to the clear. On clear clicked. It goes through and it frees up all the pointers. You know, P1 is equal to the starting pointer. Well, P1 is not null, null being false. It remembers what remembers what P1 was pointing to. It frees P1, and then it makes P1 equal to P2, in other words, pointing at the next one until it gets to null, and it's done. It sets start to null, and it queues up a draw. It queues up a draw event, which means the system will draw it. Well, when it goes down there, when the draw program comes up, function comes up, it clears the screen. And since the list structure will have no points in it, it'll be empty. That's it. It just simply returns. That's the false up here. On start, if start is null, then you return. And all you've got is a blank screen now. Okay. Now, I have got a list structure, and it's going to be a collection of points and terminated by a null. And so I'm going to need 2 points. I'm going to need a starting point and a destination point in order to do the drawing. You saw that in the last video. So I declare an integer old x and old y, which are the start. I'm always adding items to the list at the beginning. Okay. So this is always starting at the beginning. The most recent one will be at the beginning. So I take as old x and old y to be the starting point coordinates, the coordinates of the first point in the list. I set P1 equal to be the second in the list. Start arrow next, of course, is pointing at the second element in the list, which hopefully there is one. Technically, the very first time there isn't, but if P1 is null, we're done anyway. So long as P1 is not null, this is where I set the color. And I get the color from the points red, green, and blue. Okay? The red, green, and blue that are in the point become the color of the line. I then move to, these are the two move functions. First of all, I move to a starting point, then I connect a line to this second point here. So there's the starting point. It's moved to, and the parameters are actually in double, but I'm using integers because that's all you really need. I don't need that level of floating point accuracy to get my pixels on the screen. But anyway, I start at old X and old Y, okay, which is the starting point of the list. And then well, initially it's the starting point of the list. And I draw a line from there to whatever P1 is pointing to. P1's X, P1's Y. Then I update old X and old Y. So next time through, the point I just drew to becomes the starting point. And I advance. So that's all there is to it. We go through the list, going from point to point to point, drawing the line. The color, of course, we're getting out of the point. Now, how do we get the stuff into the points? Well, we've got a couple of functions here. First of all, the button press event. When you press the button, you're going to come down here, and you're going to get a widget, which I don't care about. But I get the event. The event I care about because the event's got the X and the Y in it. The event is a pointer to a structure. The structure has an X and a Y in it. And those are the X and Y I want for, that's the location of the mouse. And it's one of these, do you want to process more, not process more? So true means we're done processing. False would mean, yeah, you can go continue processing. So that's a point. The other one is motion notify. So you click the mouse, now you start dragging it. When you drag it, you're getting this one here. And again, it's the same idea. The G pointer data isn't actually used. I didn't. You could pass additional information. I didn't. It's just meaningless in here. I should have erased it, but I'm not because I have to erase it up top too. Anyway, so we get the event, and this is the same as before. And we are checking to see that the state is true and that the button mask is enabled. And if that's the case, we call the draw brush, same as above, and we pass down to it the X and Y coordinate. That's all I really care about. In draw brush, which is fairly simple, it just adds an item into the, again, we finish processing, that's why the true is here. When we get to the draw brush, all we really care about is the X and Y. I'm going to add them to the structure, so we do a malloc on the size of an instance of the structure point. So it gives me a pointer to an area of memory big enough to hold a point. If I run out of memory, you'll get an error message and it'll abort. You set the points X and Y to the X and Y that were passed into the function. You set the red, green, and blue of the point to the current red, green, and blue as defined by those functions at the bottom of the screen that are the result of clicking red, green, and blue buttons. That's where these values come from. You set next equal to start, because you're putting it at the beginning of the list, and you set start equal to P1. So you've just added it to the front of the list, and you queue up a draw event. That's all there is to it. So when you hold down the mouse, it's going to find out where the mouse is. It's going to find out as you move the mouse. Every time you move it, you're adding to this list structure. Now the list structure gets fairly chunky. I mean, there's a lot of elements in it, but it's not that big. And when you clear it, of course, it removes them. So every time you get a draw event, every time you add basically to it, it's going to repaint the entire window area. So does it work? Let me write it out in case I screwed anything up. And it compiled, and here we see it here. And again, whatever you want to do. All right. There are a whole bunch of other functions in there that allow you to draw arcs and circles and rectangles and fill things in. But if you can get to the point where you can draw stuff, you can do rectangles and circles and so forth, and you can get some funny effects by always starting at a single coordinate and drawing everything to that point. It creates interesting side effects, but you can play games with it. So there you are, and that just obviously erased the list structure, and we got a blank screen as a result. So, and that's how you terminate it there. So there is a drawing program. You get your own coloring book, but it's like proof of principle. Once you can do lines and stuff like that, you can do just about anything. Okay, we'll halt it there.